Regents Review Skill Check 2. So now, take a look at question 1, where it tells us, base your answers to questions 1 and 2 based on the information provided. So it says, in question 1, state evidence that indicates NH3 has stronger intermolecular forces. So when it says state evidence, they're typically looking at use evidence or use something from the data that's provided in like a data table, a chart, a graph, or in the reading. So use data. So we need to make a comparison. So explain why we know, based on the data provided, if NH3 has stronger intermolecular forces, or we could use the word attractions, than CF4. So I'm going to set myself up. So NH3 has a blank then CF4. Okay? So I got to look at the data. Now I have to look at the data. Can I use any of the data given, or should some be eliminated? So what kind of data might directly relate to attractions? How well the molecules stick together. So I would say, as a general rule, solubility would not be appropriate for this particular question. I would say melting point or boiling point would be better. So NH3 has some sort of, I'm going to put MP for melting point, than CF. So I see NH3 has a negative 77 compared to a negative 183. What you need to realize that could be confusing is that minus sign. So think about it. So you have a positive 10, you hit 0, and then it's a minus 10, right? So as you move down towards like minus 200, okay, which of these values would be closer to 0? So minus 77.7 is closer to 0 than a negative 183.6. So that means that NH3 has a higher melting point than the CF4, the carbon tetrafluoride. You could, so this would be one reasonable way to answer this question, or you could use the other information, boiling point. So NH3 has a blank than CF4. So maybe the other way to answer this is using the boiling point. So once again, if I look at this scaling, so as you go in this direction, we see an increase in those temperature values. So take a look. Negative 33 would be between what we already have on here, so this would be negative 33.3, and negative 127.8 would be between negative 77 and negative 183. So negative 33.3 is a higher temperature than negative 127. So once again, NH3 has a higher boiling point. And if that gets confusing, the other thing you could do, if paying attention to the negative sign makes you a little bit confused, is change these temperatures to Kelvin. So you could change to Kelvin by adding 173. And remember, on the Kelvin scale, there are no negative temps. So that might be a way to do this, because there are no negative temperatures on Kelvin. And then that might make it an easier comparison. Okay, so in question number 2, it's asking you to draw an electron dot diagram for this structure. So dot diagrams, remember, so if you look at carbon on the PT, carbon has an electron configuration of 2-4, and we only put the valence electrons in a dot diagram. So carbon's personal dot diagram would look like this. And then if you look at fluorine, it's a 2-7, so we would only put 7 dots around the fluorine. 2 at 12, 2 at the 3 o'clock, 2 at 6 o'clock, and then 1 at 9 o'clock. And in this particular compound, one of carbon's single electrons pairs up with one of the fluorine's only single electron. And take a look, our structure tells us we need 1 carbon, but we better show 4 hydrogens. So I'm going to put my carbon in the center, and I am going to put the electrons that carbon brings with it plus the one that it's going to share with the fluorine, and then I'm going to put a fluorine on each of those pairs, so the electrons we sandwich between the symbols are the shared or the bonding electrons. But notice fluorine keeps 3 electron pairs for itself, so I need to finish off each fluorine with the 3 electron pairs it does not use in a bond. So that's a lot of dots. Make sure you take your time, and it looks really neat. In this, you don't need to put the circles of sharing. But just as a side note, if I did circles of sharing, I can do that. So that's these little circles we put around, and wherever there's that overlap, that represents that covalent bond. And it's co because it's the idea of shared electrons. So that's just a little extra side note here. Okay, question number 3. So question 3 and 4, we have to utilize information given to us in this sentence. A 2.0 liter aqueous solution contains a total of 3.0 moles of dissolved NH4Cl at 25 degrees Celsius and standard pressure. So here we go. It says determine the molarity. So right away, I highly suggest go to your table T and look at the mathematical relationships that utilize molarity. And if you look at your table T, you have 2 choices. Okay, so you have molarity equals the number of moles over the number of liters. The other possibility is you have molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. So just by going to table T, knowing you have to calculate a molarity, you can get yourself down to focusing on which mathematical relationship is the best. So now to choose, you need to go back up to the information and take a look at the information given. Okay, so I see it says a 2-liter solution. So here I have a volume, and that volume is provided in liters. Okay, so both of these require liters. And when I go continue on, I see it says 3.0 moles. And so is that a capital M or is it the MOL? So the moles is the MOL. So take a look. This needs 2 pieces of information where this would need 3, and I only have 2, so I'm going to say that molarity equals the number of moles over liters is the best choice, so I'm going to use it. Okay, so that means I take my number of moles and put it in there, so 3.0 moles, and I'm going to divide it by the number of liters of solution, 2.0 liters, and when I put this into the calculator, I end up with a 1.5 molarity. That's my final answer. So in this it says determine the molarity. I don't have to show the work, but I might scrap it out on a piece of paper to make sure I'm calculating it correctly. Number 4, it says identify 2 ions present in the solute. Well, the solute is what is dissolved in the solution. So when we go back up to our information that is provided, it says that 3 moles of dissolved NH4Cl. So here we go. So this is our solute. So the information that they give us, it's NH4Cl. When it's given like this, it is given to you as a compound. the information. You have to identify two ions. You can do this pretty simply. Okay, so the two ions. So number 1 and number 2. Well, here is the first ion, okay, and I should be able to recognize that as something from table E, a polyatomic. So I'd go to my table E. NH4, it is known as the ammonium ion. So I could write down the name ammonium ion, or I could give, so I'm going to give the name, or I could give the ion symbol. Notice it says ion, so if it's an ion, that means the symbol has to have a charge. So the symbol is NH4, but if you look on table E, it'll show you that it has a +1. So the first ion, I could name it or give it symbol, and it has to have the charge. Now think about how this is named. This is not ammonium chlorine. The ion name is chloride. So it's the chloride ion, or I could do the ion symbol, which is Cl, but it uses a negative charge of 1. So -1. So ammonium ion, chloride ion, or NH4 plus, and Cl minus. Pay attention to the details.